Good afternoon, students. Today our topic with the series of abstract algebra. That is the subject name. And our topic is continuing with ring and integral domain. Now we come to the entry in the part of integral domain. So we are just ring integral domain figured this type. We are entering in the integral domain. So integral domain, a type of a ring we can say, and some properties differ from ring. The objective is such a lecture after the student have understand about the rings more deeply. Then after this, we have a small quiz. Now we come to the lecture. So, okay, student. Today we are doing some theorem based on ring. Theorem first. Prove that if a plus b all square is equal to a square plus 2ab plus b square for all AB belongs to R. Then prove that then prove that R is commutative ring and converse. Conversely, okay. Given that a plus b whole square is equal to a square plus 2ab plus b square for all a and b belongs to R. R here a ring. Then show that R is a commutative ring with and converse is also meaning a if R is commutative, then again we prove that A plus B whole square is equal to A square plus 2AB plus B square. So given we can write A plus B dot C dot pro. Now by distribution property A plus B plus B by distribution okay. Now again A dot A dot B dot C B dot. Now also given A plus B whole square is equal to A square to AB plus C is equal to by 1 we can write A dot B dot A dot B dot A plus C dot. From 1 and 2 A dot B is equal to B dot and the R is commutative. R is commutative. Conversely, take R is commutative. Now we are going to prove that R is now we take that R is a commutative ring. So we will prove that A plus B का whole square is A square plus B square plus 2A. So for that we again take whole square is equal to A plus B A dot A A plus B plus B A plus. Now A dot B dot A. We have the property A dot A is equal to A square. If ring, we have already proved that A dot B plus B dot is this. Now given that R is a commutative ring. So A dot B is equal to B dot. Now we put here A square A dot B. We can write B dot A as B dot B. This becomes A square plus 2AB. We have to do. Let's see again. I explain the theorem again. If we will let given us that A plus B of whole square is this, then we have to show that R is a commutative ring. For commutative ring, we have to show A dot B is equal to B dot. So A plus B whole square is given A plus B, A plus B. Now by distribution law we can write A plus B plus B, A plus B. Now multiply A dot B, B dot A, B dot A. So this becomes A square plus 2AB and this is common equal to this. So by 1 and 2 we get this figure. A dot B is equal to B dot A. This, so we can say that R is commutative ring. Okay. Now the conversely we assume that R is commutative ring. We take. Okay. Now again A plus B whole square become A plus B dot A plus B. Now by distribution property A plus B, A plus B. So A dot B plus A dot B, B dot A plus B dot A. Now this is commutative ring, so we B dot A we can write A dot B. So this will become A square plus 2A. Now next theorem. If R is a ring such that A square is equal to A. A square is equal to A basically is called Boolean ring. A belongs to R. Prove that if R is a Boolean ring, then prove that A plus A is equal to 0. A plus B is equal to 0 implies A is equal to B. R is commutative ring and that is E dot B is equal to B dot A. This is the coefficient asking BHU at R levels. Last one. And this is also the previous one. Already must ask many times this question in 80. So A part. E belong R. So by Boolean link we can write by given is here we can write E plus A plus A. Here we can write A square plus A square plus we can write here E plus A plus because A square is equal to B. So we can if we take x, okay, so we can write A plus B plus A plus A. We can write by 0 plus A. So x plus 0 is equal for our x belongs to. So we can write E plus A is equal to 0 by left cancellation. Cancellation. This is the part. First, now we come to the part second. A plus B is equal to 0. So A plus B is equal to 0 means A plus B is equal to A plus A because we have A plus A is equal to 0. We know. We prove already proved. We prove. Okay. Now by left cancellation we can write A is equal. It we cancel this. Y can. Or see, if A belongs to R, B belongs to R, then A plus B belongs to R. Because for addition, R is a abelian group and group is satisfies the condition of closure. So if A belongs to R, A belongs to R, A plus B belongs to R. And A plus B by given condition. Okay. Now A B by distribution. My distribution. Okay. So friend we can write here like A square plus AB equals this. Now we can write A square is equal to A. So A plus BA plus A. Okay. So by consolation law BA plus AB. So here you can is equal to 0. So BA is equal to AB by cancellation. Cancellation. A plus B is equal to 0. And R is now we come to the ring with zero divisor. A ring R is without zero divisor if and only it follows cancellation. Or fin a ring R is without zero divisor if and only if it follows cancellation law or holding. Maybe write in holding R. Okay, this is very important theorem. Many times it asked in Rajasthan University 83, 74. Right. So, proof R is without zero divisor. That means that means AB is equal to zero implies A is equal to zero or both. Both is zero. To prove that AB is equal to BC, AB is equal to AC, not zero implies B is equal implies this. Now AB is equal to BC, B, C minus. Sorry, AB is equal to AC, then is equal to zero. But since the ring is without zero divided, without zero divided, then either or both A and BC, B minus C should be zero. Should be zero since A is not equal to zero, B minus C that is okay. Hence cancellation law that means cancellation law is followed by T. AB is equal to we know when ring is without zero divisor AB is equal to zero, A is not equal to zero, B is sorry A or B either A or B is equal to zero or what maybe what because there is no term to, to multiply with each other give the result 0. So AB is equal to 0 while A is equal to 0 or B is equal to 0. Now we have to prove that AB is equal to AC when B is equal to C. So we take AB is equal to AC, we take A common and B minus C. So either A is equal to 0, either B minus C is equal to 0 because this is the ring without 0 divisor. So it follows the B is equal to C, so it follows the cancellation and the cancellation will convert. Convert cancellation let the ring hold the cancellation. To prove that the ring is without zero divisor, let us suppose assume that the ring is with zero. So AB is equal to 0, A is not equal to 0. Here, for prove that it is without zero divisor, ring is without zero divisor. So we assume that this is the with zero divisor. With the contradiction property, we will prove that this ring is without zero divisor. So we take AB is equal to 0 where A is not equal to 0, B is not equal to 0, but their product is 0. So this is the ring with zero divisor. Okay. Now, now, now AB is equal to 0. That implies A is equal implies B while we can write like that. This can be written in AB A dot C. By cancellation B. So by cancellation cancellation law which contradiction which is contradiction. Which is contradiction. So contradiction is contra contradiction contradiction and and our assumption that the ring is Which zero divisor is wrong and such that and as such it is a ring without okay students, let's explain again. This is very important theorem. Let a ring is without zero divisor. Given us a ring is without zero divisor. If and only if it follow the cancellation law. Cancellation law means AB is equal to AC, then B is equal to C. Okay, we cancel the A. So take we R is without zero divisor. So we take AB is equal to 0. Maybe A is equal to 0 or B is equal to 0, or we can take both 0. So then AB is equal to AC. So that this, so AB is equal to AC for cancellation law. We take AB is equal to AC. So we take this side become AB minus C is equal to, we have to prove that. We will show this. We will show. Okay, B is equal to C. So AB is equal to BC, AB is equal to AC, sorry. Then implies A taken common, B minus C is equal to 0. Since this is the without zero divisor. So A should be 0. Let two element product with 0. Then A is equal to 0 or B minus C is equal to 0. Either A is equal to 0 or either B minus C is equal to 0. So if A is equal to 0, then it's okay. But if B minus C is equal to 0, then we get B is equal to C. That means we can say B is equal to, that means the cancellation law. Okay. Now converse is converse taken. Let the ring hold the cancellation law. Now we will show that cancellation law hold by the ring, and this type of ring without zero divisor. So prove that the ring is without zero divisor. And student, you give me example of ring without zero divisor. Yeah, the set of integers. The algebraic structure Z plus dot is the ring without zero divisor. Always this ring is without zero divisor because there is no um, dot product inverse. AB is not equal to 0. There must be AB is equal to 0 when A is equal to 0, B is equal to 0. Let we assume that R is with zero divisor. So AB is equal to 0. We have A is not equal to 0 or B is not equal to 0. And AB is equal to, we can write, if AB is equal to 0, we can write AB is equal to A dot H. Implies we know that the ring holds the cancellation law. So A to A cancel, become B is equal to. So by cancellation law, which is contradict, we assume that the ring is with zero divisor, but there is a contradiction. So we can say that ring with without zero divisor. Question. Now there are some assignment or homework for you. You can try by yourself to prove. Try to So that these are the ring A, two operations, two binary operations, star and O on the set Z. Z. Z is the set of integers. Are defined as under A star B is equal to A plus B minus 1 and A O B is equal to A plus B. Then prove that Z star O is a commutative ring. This is a question for your assignment. You can try yourself to build up your confidence in ring. Now, the time for the quiz. I return to my presentation. There are some questions waiting for you. That which of the ring is commutative ring with unity? So, Z plus dot set of integer and plus dot and 2Z plus means the set of algebraic structure a ring of even integer and all are true. So one by one n plus dot I many time discuss with you with all of you that n plus dot is not a group. N plus dot n plus is not a abelian group or group. Then it is not possible that is the ring. Okay, so the option is cancelled. Now become to Z plus and Z plus. Commutative ring, Z plus dot is commutative ring because if we multiple commutative law followed by both Z plus and 2Z plus. But with unity 2Z plus have no identity element for multiple identity element is 1. So this is not in 2Z plus. So the right option is Z plus dot. Z plus dot is a ring is commutative ring with unity. Understand? The ring has a property AB is equal to 0 for AB not 0. Either A is not 0, B is not 0. AB is equal to B when commutative ring CR commutative ring. ABC is not CR. Okay, student. AB is equal to 0. I told you AB is equal to 0. A and B are not 0. This is the form of ring with 0 divisor. Ring with 0 divisor. So this is not possible in ring. AB is not 0. This is AB is 0 when A and B not 0. So A is option wrong. AB is equal to BA. This is the right action when CR given is the commutative ring. So this is property of a ring at AB is equal to BA, then we call ring with commutative. Which statement is not true? 2Z plus is a CRU and Z plus B is CRU. Z plus is a field. I am just tell you about field because sometimes many questions ask about the field. Field is that simple word you can say is multiple. Each element or multiple have inverse adjust. This follow all the you can say कि z dot is r dot is also a abelian, not abelian. We can say group. A ring is called a ring r plus dot is called field when every element have the multiple inverse in it. A CRU is also z plus dot be a CRU, 2z plus is a CRU, z plus dot is a CRU, z plus dot is a filter set of integer, a set of algebraic structure of z plus dot is not a field. It cancel C is cancel wrong. 2z plus dot is not a CRU because it has not unit element. In previous question I told you. And z plus dot be a CRU. Definitely z plus dot is a CRU. Which statement is true? N plus is a CRU. N plus is never the CRU. The ring has zero divisor. That's wrong. C plus dot is a field. बिल्कुल सही. C plus dot is a field. That is definitely right answer. So, students, thank you very much for listening me, and I hope this ring and group and field integral domain is helpful for you in abstract algebra. Okay, thank you very much. Don't be confused about the z plus dot to z plus dot. You revise the lecture continuous basis, then you have to clear. I repeat question, but language change करके I repeating the question again and again for practicing. Like n plus dot. Many time I asked this question by any different way. Okay. Thank you very much.